Hey there, Focus Learners, and welcome back to another Explainer. So today, we're diving into one of the absolute most fascinating and, honestly, kind of terrifying paradoxes in all of human history. We're going to look at why humanity's ultimate scientific dream is actually, mathematically speaking, a total nightmare. Yeah, we're talking about the search for extraterrestrial life, and I promise you, by the end of this, you are going to look up at the night sky in a totally different way.
I want you to just imagine something for a second. What if NASA called an emergency press conference literally today and announced they had finally found aliens? Just picture it. Maybe they found living bacteria on Mars. Or, they drilled down into the ice of Europa and found some weird glowing alien fish swimming around in its dark oceans. Or, even crazier, what if they found actual crumbling ancient ruins on Titan? I mean, most of us would be popping champagne, right? Wouldn't that be the greatest news ever?
Okay, let's dive into this, because the reality, it's the exact opposite. It would be horrible news. Actually, it would be downright devastating. Why? Well, because discovering that life is common in our solar system almost certainly means the end of humanity is coming, and it might be coming very soon. To understand exactly why the most exciting discovery of our lifetimes would actually spell our doom, we really need to look at how life progresses in the first place.
Section 1. The Staircase of Life.
To really wrap our heads around this, let's imagine the development of life from its absolute dead inception all the way to us sitting here today as a giant flight of stairs. Every single species has to climb these exact same logical steps to survive and expand. Step 1, dead chemistry somehow has to magically assemble itself into self-replicating patterns. Step 2, that early life has to get more complex, eventually mashing together into multicellular beings. Step 3, a species evolves big brains, figures out tools, creates culture, and basically dominates its home planet. Now, because planets have a limited lifespan and carrying capacity, a surviving species absolutely has to expand. So, Step 4 is colonizing your own solar system, and Step 5, the very top of the stairs, is becoming a massive galaxy-wide civilization. Now, what's incredibly interesting about this evolutionary climb is figuring out exactly where we are on it. Humanity is currently taking our very first, kind of shy attempts at stepping from level 3 up to level 4.
Keep that staircase in mind as we look at this absolutely staggering number, 500 billion. That is the estimated number of planets in the Milky Way galaxy alone. And out of those, at least 10 billion are Earth-like planets. Crucially, a lot of those planets have been around for billions of years longer than Earth has. If the staircase of life is a universal rule and species naturally spread out to survive, well, there's been plenty of time and plenty of prime real estate for countless galactic civilizations to just conquer the stars.
But then we actually look out into the universe, and we get this number, 0. We have observed exactly 0 galactic civilizations. I mean, we should be able to see something, right? Our telescopes should be picking up megastructures, or rogue radio waves, or entire colonized star systems. But there's just nothing. Space is filled with completely dead silence. This dead, empty space forces us into a very serious, totally inescapable conclusion. Section 2. Entering the Great Filter. So if the universe is old enough and big enough for life to just be everywhere, but space is completely empty, it means something is violently preventing living things from climbing that cosmic staircase. Something out there is stopping them dead in their tracks beyond the step we're on right now. The Great Filter is a challenge or a danger so incredibly hard to overcome that it eliminates almost every single species that encounters it. It basically makes becoming a galactic civilization practically impossible. And based on this theory, there are really only 2 possible scenarios for humanity.
Section 3, Scenario 1. We are rare, and the filter is behind us.
This scenario is filled with a sort of optimistic dread. It basically says we are incredibly special. We are phenomenally lucky. In this scenario, the Great Filter is already in our rearview mirror. It means one of the steps we've already passed on that staircase was just so impossibly difficult that almost no one else in the entire universe has ever made it this far. We're the first. So the really crucial question becomes, which of the steps behind us was the Great Filter? There's a few prime candidates. Maybe life itself is extremely rare, and dead chemistry sparking into living patterns just almost never happens. Or maybe the filter was the leap to complex animal cells. Or perhaps the massively expensive evolution of big, intelligent brains is just a hurdle that 99.9% of life in the universe totally fails to cross. Let's actually look a little closer at that second possibility.
See, a very specific biological freak accident happened exactly once in our entire planet's history. A primitive hunter cell swallowed another cell. Now, usually, it would just be devoured, end of story. But instead, they formed a union,
The bigger cell provided shelter and resources, while the smaller guest used its new home to provide a massive amount of extra energy. The guest literally became the powerhouse of the cell. This one-time microscopic merger is the basis of every single animal on Earth today. Without it, we simply wouldn't be here. Maybe billions of planets out there are just stuck with basic bacteria because this wild union never happened for them.
Or, maybe the great filter was our intelligence. We love to feel very sophisticated with our romantic novels and our Sunday crossword puzzles, but biologically speaking, a big brain is an incredibly expensive evolutionary investment. Big brains do not help you in a fistfight with a bear. They're fragile, they cost massive amounts of energy to run, and even with them, it still took modern humans 200,000 years just to get from pointing sharp sticks at things to actually building a civilization. Being smart doesn't automatically mean you win the evolutionary lottery. It might just be a miraculous fluke that it actually worked out for us.
Section 4, Scenario 2. We are doomed and the filter is ahead of us. And this brilliantly illustrates the flip side. Because if those past steps weren't actually that hard, and life naturally evolves complex brains all the time all over the universe, well then plenty of other alien species have climbed the stairs right up to where we are, and then they died. But before we hit the panic button, we have to carefully distinguish between a setback and a true filter. A roadblock is a major disaster. Maybe it throws us back thousands of years into the Dark Ages, but we eventually survive and recover. On universal timescales, taking 1,000,000 years to rebuild is just a blink of an eye. That's just a roadblock. A great filter, on the other hand, is purely devastating. It is so dangerous and so powerful that it definitively destroys most, if not all, advanced civilizations in the galaxy. It wipes the slate completely clean.
So, what exactly could a great filter ahead of us look like? It has to be a technology or an event so obvious that virtually every advanced civilization eventually stumbles upon it, and so dangerous that it almost universally leads to existential disaster. I mean, we can already see these terrifying threats looming ahead of us right now. Large-scale nuclear war, runaway nanotechnology that gets totally out of our control, genetically engineering a perfect superbug, high-energy physics experiments that accidentally ignite the atmosphere, or, of course, the creation of a super-intelligent rogue AI that purposely, or even accidentally, destroys its creators.
Or maybe the great filter is even simpler than all that, and much more depressing. The really grim hypothesis here is that any species competitive and driven enough to take total control of their entire planet will necessarily destroy that planet while competing for its resources. They trigger runaway ecological chain reactions that just cannot be fixed, meaning once a civilization is powerful enough to fundamentally change its atmosphere, they make their planet uninhabitable 100% of the time. Let's just really let that sink in for a second.
Section 5. Why empty space brings hope.
So, let's bring this all together and resolve that initial hook. Why is the empty, dead silence of space actually exactly what we want to hear? Consider the alien danger scale. If the great filter is ahead of us, our odds of survival are basically zero. But if the universe is empty, it strongly suggests the great filter is already behind us. Every single level of life we find out there drastically increases the odds that the great filter is still waiting for us in the future. Think about it. Finding bacteria on Mars? That would be bad, because it means life starts easily, so the filter isn't step one. Finding small animals on Europa would be worse. It means complex life is common. Finding intelligent life would be straight up alarming. And finding the ruins of an ancient alien civilization on Titan? That would be absolutely horrifying. It would prove that you can climb the stairs all the way to a planetary civilization and still get wiped out.
Therefore, the absolute most comforting thing we can possibly find in space is absolutely nothing. The best-case scenario for us right now is that Mars is sterile, that Europa's oceans are completely devoid of life, and the vast arms of the Milky Way harbor only empty oceans hugging dead continents. I know, it sounds incredibly lonely, but recognizing this truth brings a profound sense of relief. A beautifully empty universe is quite literally the greatest, most hopeful news humanity could ever receive. Because an empty galaxy means the hardest part is over. We survived the great filter. And what lies ahead of us isn't some guaranteed, inescapable doom. What lies ahead are billions of empty planets, just waiting to be discovered, waiting to be filled with life. Billions of new homes, waiting for us to finally arrive. So what do you think we're going to do with all that space? Keep climbing those stairs, keep learning, and I'll catch you in the next explainer.